So in this video, I'm going to introduce a concept that we'll go into in more detail in a later video, and that is the idea of the colon operator. So the reason that I want to introduce this now is I introduced this concept within Lab 1 in order to define a discrete index of times for which we actually compute the value of the voltage in that RC current. So generally speaking, the colon operator is going to be incredibly useful when you want to define a vector of values, typically integers, but they really can be any real number that are evenly spaced. So there on the third bullet point, we've already talked about techniques to explicitly define vectors of numbers by listing the actual values and then separating them by the delimiters of commas, which basically make them into a row vector. So just kind of going into MATLAB and seeing how this actually works here. I think the first example I showed you is I'm going to pick a valid variable name, something like x, and I'm going to assign that variable equal to. I'll use the square brackets to tell MATLAB in general to expect a matrix. Of course, a vector is a particular subset of a matrix. And then I could explicitly enter in all of the values that I would like to put within my vector, in this case 1, 3, 5, 7, and 9. And then I could close these square brackets, letting MATLAB know that I'm at the end of actually defining my vector. And I'm intentionally not going to terminate it with a semicolon because I would like MATLAB to actually spit out the values on the command window and show me what it is stored in the variable x. And you'll notice that MATLAB is echoing that it is stored in the variable x, the vector of values 1, 3, 5, 7, 9, and that is arranged in an actual row. So as an alternative to that, I could also have defined, and I'll pick a new variable name just to not overwrite the variable that I previously defined within my workspace. Let me just actually write the notation here, and I'm sure you'll be able to see the pattern. So if you notice, relative to the numbers that I've defined above, 1, 3, 5, 7, 9, here I have the numbers 1 and 9 on the end, and I have the number 2 in the middle, and they're actually separated by a colon. So colon notation, what that really does is it takes and creates a vector starting at the first element, ending at the last element with a spacing of the element in the middle of the colons. So this is going to start at 1, go up by 2, all the way until you get to 9, then it will terminate. So starting at 1, 2 forward is 3, 2 forward is 5, 2 forward is 7, and 2 forward is 9. So basically the reason that I chose my inner element spacing of 2 is I saw that in the vector I wanted to define, that was the common pattern. That's what the individual values in that vector had in common. So that is how I actually specified it. And you see here that the syntax for the colon operator is you specify your starting value first, then you specify your step, and then you specify your ending value or your stop value. And notice that by default, that actually creates a row vector, in addition to just actually having the values repeated on the command window by not using an actual semicolon. Echoing is the word I was looking for there. Of course, we can look in our workspace of our user interface and note that both of these vectors not only have identical values, but are of size 1 row by 5 columns. And the reason that they are of that size, in the case of the colon operator, that is the default vector that it generates. In the case of explicitly defining the elements with commas, that is how commas are interpreted in MATLAB, is to basically go in the same row to the next column. Of course, we've talked about before, and we'll continue to emphasize throughout the course, if you wanted to stack them vertically instead of stacking them horizontally, you wouldn't use, in the explicit case, commas, you would actually use semicolons. So let's actually look at a couple more examples just to emphasize some more points. Example 1, define the following array in MATLAB using the colon operator. Is the spacing of 1 necessary in this case? So if you notice this vector, first question, if we want to use the colon operator, there better be an equal spacing between elements. From 3 to 4, that's a difference of 1. From 4 to 5, that's a difference of 1, and so on. You notice that the spacing between elements is 1 here. It starts at 3, and it actually terminates at 7. So rather than explicitly listing all of those elements, I could go into MATLAB and define my vector y as through the colon operator, beginning at 1, stepping by, I think it's beginning at 3, rather, stepping by 1, and then terminating at 7. And that will generate what I was looking for in this case, 3, 4, 5, 6, 7. But just note that, and this is often the case when you have operators in computer science, they're overloaded. There is some default conditions that you don't have to enter all of the information for. And it just so happens with the colon operator, if you don't enter an actual step, If you just say, I want to go from 3 to 7, it will by default assume that you want to step by 1. So that's what I mean by the question of, is the 1 necessary? The 1 is not necessary because the default assumption, if a step isn't listed, is that you're stepping by 1. Example 2 here, define the following array in MATLAB using the colon operator. This might not look like an example for which the colon operator could be defined, because in this case, the values are actually decreasing. However, if you look, there still is a constant step between the elements, from 9 to 7 to 5 to 3, and each step is just decrementing or going down by 2. So you can have a negative step. That's the reason that I did this example. So starting at 9, if I step by -2 each time and I go all the way to 3, I can generate this actual vector. So let's do that. Let's define the variable m as containing the values beginning at 9, stepping down by -2 is how we indicate that, and then actually terminating at 3. And you notice in that case, you get a result, 9753, that is identical to what we were trying to generate. So just know for now that the colon operator is a very efficient way to generate equally spaced arrays without explicitly typing in all of the numbers, and that by default, it generates a row vector, and that if a step or a spacing is not specified for that middle argument in the syntax of start, step, stop, that step will actually default to 1.